Hello students, welcome to another session of mathematics, and today's session is the last session for mathematics as well as the last session of the MCQ discussion of YouTube live channel of Brilliant Qatar. Okay, so today's discussion is on the topic of integrals, very important topic for your MCQs. Today purely we're going to be discussing only on integrals, and please share the link to all your friends and ask them to join immediately before it's too late, and please subscribe to our channel to get the latest videos on all the recordings and the live sessions you will be seeing again from Brilliant Qatar. So let's go to the discussion straight away, all of you. Question number 1. If the derivative of f of x is 1 by 1 plus x squared, then what is the derivative of f of x cube? So we have the derivative of f of x. I can say that the derivative of f of x is equal to 1 by 1 plus x squared. Then what is f of x? It's simply the integral of 1 by 1 plus x squared, which is tan inverse x. A question related to this idea, which is called antiderivative. The inverse of derivative is integral. So integral is called as antiderivative, is expected. So what is f of x? The integral of 1 by 1 plus x squared, which is tan inverse x. Therefore, what is f of x cube? It is tan inverse x cube. Now I want to find the derivative of f of x cube. So the derivative of tan inverse x cube is 1 by 1 plus x cube squared into the derivative of x cube. The final answer, 3x squared by 1 plus x raised to 6. Once again, the idea for this question is, I needed to know what was f of x. So I applied the idea of antiderivative. The antiderivative is the integral of 1 by 1 plus x squared. Yes, right answer started coming already. Yes, Sana, Adil, Hafiz and Abin. We have option B, 3x squared by 1 plus x raised to 6. The idea of antiderivative, my dears. So you might feel the question is about derivative, but no. If you have a complicated question about derivative, just invert it, you will get antiderivative, which is integral. Question number 2. Integral x squared ex cube. It looks like isolate, but I will not apply isolate here because, or the integration by parts, because e raised to x cube is not an integrable form. Substitution is much better. Substitution is much better. So I'm going to put t is equal to x cube. Then what's the derivative of t? 3x squared dx. Yes, so dt by 3 is x squared dx. Use that as a substitution, all of you. So you will get x squared dx is dt by 3 and e raised to t. That is 1 by 3 e raised to t, which is 1 by 3 e raised to x cube plus c. Option? Yes, right answer, option A, 1 by 3 e raised to x cube plus c. Do not go for integration by parts because it's e raised to x cube. E raised to x is the integrable form, not e raised to x cube. So substitution is preferred. Derivative of x cube is 3x squared, and we get to the answer. Question number 2. Okay, I hope everybody is clear with question number 2. Yes, very good. Right answers, all of you. Okay, moving forward. Question number 3. E raised to x 1 plus x by cos squared e raised to x into x. Again, cos squared is actually 1 by cos squared is sec squared. Yes, sec squared is an integrable form, but whatever is inside is not an integrable form. So whenever we have a non-integrable form, the idea is substitute that as t. So e raised to x into x is substituted as t. So what's the derivative of that? Use product rule. 1 e raised to x plus x e raised to x. Product rule, derivative of x into e raised to x plus x into derivative of e raised to x, which is again e raised to x, dx. So what's dt? 1 plus x e raised to x dx. You can see e raised to x is common, take it out. So can you see that this entire term is going to become dt? So my integral is now going to be integral of dt by cos squared t, and 1 by cos squared t is sec squared t. And what is the integral of sec squared t? What is the integral of sec squared t? Tan t plus c, and substitute t, which is x into e raised to x plus c. Option B. All of you, option B. Tan x e raised to x plus c. Right answer: Samuel, Adil, Sana, Hafiz, Jed, Hadia, Abin. Okay, the answer is tan x e raised to x plus c. So once again, keep your idea in mind. We know 1 by cos squared is sec squared, which is an integrable form, but whatever comes inside sec squared should be a linear form, but x into e raised to x is not a linear form, so we substitute that as t. Keep this basic idea in mind. You will be able to understand a question of substitution. Next, question number 4. It looks like 1 by quadratic. Integral of 1 by quadratic. So what should you do with this? You have to convert x squared plus 2x plus 2 in the form of x squared plus a squared, or x squared minus a squared, or a squared minus x squared, using completing the square method. So if you use completing the square method, this is going to be x plus 1 squared minus 1 squared plus 2, which is x plus 1 squared plus 1 squared. There are many students who might know how to do it, but if you are not familiar with how to write the completing the square form, please refer to your regular books. You will get it. There's no time for explaining all these things now. I have now expressed it as x plus 1 squared plus 1 squared, which is x squared plus a squared. Now I'm trying to do the integral of 1 by x squared plus a squared, which is equal to 1 by a tan inverse x by a. Substitute this correctly in the expression. A is 1, so 1 into tan inverse of x plus 1 plus c. So tan inverse of x plus 1 plus c, option B. Yes, Adil, Samuel, Sana, Abin and Adin. Tan inverse of x plus 1. A question based on the direct formula of particular functions, special integrals, is also expected for MCQ from integral parts. So learn how to complete the square for a quadratic form and apply the relevant formula. Okay, please, my dear students, it's very important to learn how to complete the square and apply the relevant formula. Moving on to the next question, my dear students. Again, one more. It's a quadratic form, so a bit more difficult, not that easy. It's 9x minus 4x squared. According to the idea of completing the square, the coefficient of x squared should be positive 1. So I'm multiplying and dividing by minus 4. So you will get x squared minus 9 by 4x. This is the quadratic equation which I'm going to complete the square with. Okay, x squared minus 9 by 4x. So if I complete the square for that, it is going to be x minus 9 by 8 squared minus 9 by 8 squared. This is the completed square form for this. But whenever you have a negative outside the bracket, please make sure it is going back inside. Okay, Only constants are allowed, so you have to take the negative back inside. Now the expression is going to look like 4 times 9 by 8 squared minus x minus 9 by 8 squared. This is like a squared minus x squared, my dears. This is a squared minus x squared, and it is under a square root. Okay, apply the integral, all of you. Integral of dx by square root of a squared 9 by 8 squared minus x minus 9 by 8 squared. Don't forget there was a 4 also. What's the square root of a 4? Which is 2. Leave it as 1 by 2 outside. Now what is 1 by a squared minus x squared? 1 by a squared minus x squared. Sine inverse x by a. Sine inverse x by a. Apply LCM inside. Half sine inverse 8x minus 9 by 9 plus c. Half 8x minus 9 by 9 plus c. Half sine inverse of. Okay, again option B is your answer. This part of the completing the square you should keep practicing regularly. You can go to your textbook where the exercise of particular functions are there in chapter 7. Take the exercise. You will see a lot of quadratic forms in that. Try completing the square with that. We are expecting a question for 1 mark where you're completing the square and applying it in the correct formula straight away. So please practice them. Yes, it's important for 3 mark also. So practicing this is not going to be a problem for you. It's not a wastage of time. So please practice completing the square, my dear students. Okay? Fine. Question 6. Find the value of 0 to 1, 2x minus, it's a definite integral question. 2x minus 1. I want everybody to take a close look at it. It's a 1 mark question. So don't think you're going to do it with linear by quadratic, okay? Don't think you'll be doing with linear by quadratic. It's useless because it's just 1 mark. Linear by quadratic is a standard question for 3 mark. Look at the denominator and see that if I take a negative out from this, you will get x squared minus x minus 1 dx. Yes? Do you see that the numerator is the derivative of the denominator? The numerator is the derivative of the denominator. We can use the standard result. F dash of x by f of x is log f of x. What is the standard result? Integral of f dash of x by f of x is log f of x. This is f dash x. This is f of x. So answer is going to be minus log x squared minus x minus 1, and the limit is from 0 to 1. If I apply 1, it's 1 minus 1 minus 1. Okay, so it's going to be log mod minus 1. Again, if you put 0, 0 minus 0 minus 1. Again, log mod minus 1. Mod minus 1 is still 1. Log 1 is 0. So your final answer is also 0. Option B. Option B. Yes, right answer Hafiz, Abin, Hadia, Faras, Sana and Adil. Okay, so we are getting the answer 0 here. So please be careful. Once again, you have to not do it with linear by quadratic. It's a 1 mark question. So definitely something like the derivative form is existing. Check it. What's the standard result for integral f dash by f? Log mod f. Log mod f. Okay. And what is the standard result for f dash of x by square root of f of x? If you want, you can learn this also. 2 times square root of f of x. 2 times square root of f of x. These are very good standard results which can be used for 1 mark MCQs as well as for 3 mark questions. Okay. Next question number 7, all of you. The value of sec squared log x by x. So here let us put, again Very clear. Sec squared is an integrable function, but log x inside sec squared is not. So that should be substituted. So t is equal to log x. What's the derivative of t? 1 by x dx. We have that here, right? Dx by x. Now what you do here is, you take the integral, you get sec squared t dt. And what is the integral of sec squared t? It is tan t plus c. What is the integral of sec squared t, all of you? The integral of sec squared t is tan t plus c. That is equal to tan t. T is log x plus c. Tan of log x plus c. Again, option B. Again, option B. Yes, Sana, Nidin, Faris, Hadia, Ritika, Kevin, Angelin, all of you right answer. Okay, so all of you listen once again. The idea for method of substitution, and a method of substitution is the most expected question for 1 mark MCQ from integrals. Remember, you would have an integrable function like sec squared or like anything else like integrable function, but the function inside that integrable should be substituted as t. It's the most common question, my dear students. It's easy to assume also. Okay, fine. Get it. Question number 8. Very interesting question. Did you understand what is that small 0 doing on top of x? It's not a 0 actually. It's degrees. It's sec x degrees tan x degrees. We have a formula like this in integration. Can anyone in the class tell me what is the integral of sec x tan x? Quick. What is the integral of sec x tan x? Most of you started giving answers. Yes, one answer already, 2 answers already came. Yes, Samuel, right answer. Integral of sec x tan x is sec x plus c. Yes, right answer, Abin, Faris and Hafiz, sec x plus c. But this x is in radians. Keep in mind, my dear students. That's why we don't have a symbol on top of it. Okay, all the formulas of trigonometry, whether be it differentiation, whether be it integration, whatever it is, they are talking it in terms of radian measures. That's why whenever we apply definite integral limits, they are also given in terms of radians. Not 30 degrees, 45 degrees. It's like pi by 6, pi by 4, pi by 3, pi by 2. All are in radian measures. So they always measure trigonometric angles in differentiation, integration based on radian measures. But this is degree measure. So how to convert this x degrees to radians? 11th standard idea. How to convert x degrees to radians? Multiply it with what? Multiply it with what? Pi by 180? Pi by 180? Yes? Yes? Pi by 180, when multiplied with x, you will get what? Radian measure? Yes? X degrees multiplied with pi by 180 will give you radians, right? Yes or no? So what you should do now, all of you, what you should do now to make this x degrees to radians? Quick. How to make it into radians? Quick, all of you. Multiply with pi by 180, right? So I can write the sec as sec pi by 180 x tan pi by 180 x. Simply multiply it with pi by 180. Okay? Now apply the formula once, my dear students. When you apply the formula, what is the integral of sec x tan x? It is sec pi by 180x plus c. But according to the integration of linear forms, what is the integral of sec ax tan ax dx? When there is a coefficient for x, what would you do? The answer is sec ax divided by the derivative of ax, which is a. Similarly, you have to divide it with pi by 180. And when you divide it with pi by 180, it becomes 180 divided by pi into sec of pi by 180x can be taken back as degrees plus c. The first answer I got in the class was option B, because that student was directly thinking the formula but never thought about the degree over there. But I got the same answer, but I got 180 by pi as a coefficient here because I am dividing with the pi by 180 in the answer, which I've used to convert it as radians. So my answer is option C. Got it? Yes, right answer coming from Nitin, Prapti, Albert, Hafiz, Sana, Jed, Faris, Adil and Kevin. So learn, my dear students. The normal question is sec x tan x, but when it's in degrees, multiply each x with pi by 180 and then put it back to make it as degrees. Okay? I believe everybody is clear with the idea. Moving on to question number 9, all of you. Integrate mod x dx. Integrate mod x dx. Normally, if it was a definite integral question, you would have practiced this in regular classes. How to integrate a modulus function. You will split them as positive and negative. Here also, let's split it. Modulus of x can be split as positive x for all values of x greater than or equal to 0 and negative x for all values of x less than 0. So if you try to integrate mod x, you will get two answers, all of you. The integral of x and the integral of negative x. And please tell me what's the integral of x. Integral of x is x squared by 2 and the integral of negative x is negative x squared by 2. So possible to get two answers. Anyway, answer A is wrong because answer A says x squared by 2 is the only answer, but I'm getting two answers. Answer B alone is wrong. Answer C is x mod x. Try to analyze this answer, my dear students. What is actually x mod x? I'm trying to analyze what is x mod x. X mod x can be either x into positive x or x into negative x. Positive x for greater than 0, negative x for less than 0. So it's actually positive x squared when x is greater than 0 or negative x squared when x is less than 0. But definitely my answers are x squared by 2 and minus x squared by 2. So it's not x mod x. Wrong answer. What about this one? X mod x by 2. So it's x squared by 2 or minus x squared by 2. So answer is option D, half x mod x plus c. Answer is option D. Right answer, Prapti, Faris, Hafiz, Raghavendra, Adil, Sana, Shadi, Ritika and Abin. Very good students. So I'm happy some students got the idea about this question. So what is the integral of mod x? If it comes in the exam, sir, I don't want to do this all things. No need. What is the integral of mod x? Now you know that the integral of mod x is x mod x by 2. X mod x by 2. Okay, good. Question number 10 now. Integrate tan inverse x. It's a normal question. You don't know how to integrate tan inverse x? It's an inverse trigonometric function which is not an integrable function. You simply multiply it with 1 and you do what? Integration by parts. When you do integration by parts, it is the first function multiplied with the integral of 1 minus the integral of derivative of tan inverse x into integral of 1 dx. So the answer is integral of 1 is x tan inverse x minus derivative of tan inverse x is 1 by 1 plus x squared into x dx. Now just for my convenience, I am putting a half here and I am multiplying 2 here. So that the integral now looks like integral of f dash by f, which we have seen already as log f. In the previous questions, we saw it. Integral of f dash by f is log f. Yes, right answer is already coming. I can say it. So answer is x into tan inverse x minus half log 1 plus x squared. X tan inverse x minus half log 1 plus x squared. Option D. Option D. X tan inverse x minus half log 1 plus x squared. Right answers all of you. Prapti, Bablu, Adil, Faras, Abin, Nitin, Jed and Ebin. Good. So it's a simple function which is done using integration by parts. Moving forward, question number 11. Integral of. It's a very standard question. It has been coming commonly in many of the schools this time. So please, it's good to learn it. So please learn it, all of you. 1 by sine squared x cos squared x. It can be done in many ways, but the most common one is write 1 as the trigonometric identity sine squared x plus cos squared x by sine squared x cos squared x dx. Okay, sine squared x plus cos squared x is 1. So use that identity to write the numerator. Split the numerator. You will get sine squared by sine squared cos squared, which is 1 by cos squared. Cos squared by sine squared cos squared, which is 1 by sine squared. So what is the integral of cos squared? Sec squared x. What is the integral of sine squared? Cosec squared x. So what is integral sec squared? Tan x. And what is integral cosec squared? Minus cot x plus c. Final answer, tan x minus cot x plus c. Many of you gave the right answer, so I don't want to say the names again. Right answer from many of you, option B. So what's the idea here? Write the numerator 1 as sine squared x plus cos squared x using the trigonometric identity. Question 12. Very interesting question. Very awkward form seen here. So whenever a question like this comes, it looks very awkward. Keep in mind, definitely it's a question of method of substitution. But the problem is what to substitute. I have 3 forms, 5 raised to 5 raised to 5 raised to x 3 times. Then 5 raised to 5 raised to x 2 times. And then 1 5 raised to x. I will take the middle term. It's a very good question. Take the middle term and put it as t. Okay, it's best to put the middle one as t, so you can easily connect it with the last one and the first one. What's the derivative of a raised to x? I want everybody to think about the derivative of a raised to x. It is a raised to x into log a. Okay, but if I try to apply chain rule, it will be taking like derivative of a raised to f is a raised to f into log a into derivative of f. Chain rule, right? Same idea. What's going to be dt then? This is a for you and this is f for you. Apply the chain rule here. It's going to be a raised to f into log a into derivative of 5 raised to x. Apply that once again. So 5 raised to 5 raised to x into log 5 into 5 raised to x into log 5 dx. Derivative complete. So what's my dt? My dt is dt by log 5 squared is equal to 5 raised to 5 raised to x into 5 raised to x dx. Listen all of you. 5 raised to 5 raised to x into 5 raised to x dx is your answer. Dt by log 5 squared. dt by log 5 squared. Apply that and you will get your integration now as, this whole thing is t, my dear students. It is integral of 5 raised to t multiplied with dt by log 5 squared. It's a basic integration, integral of a raised to x. I hope everybody knows it. Integral of a raised to x is a raised to x by log a. Okay, but there is a log 5 squared already, it becomes cubed. Substitute back t, my dear students. When you put back t, it's going to be 5 raised to 5 raised to x divided by log 5 cubed. Answer option C. So explanation is what took so much time, but the idea is very simple. Call the middle one as t and the derivative by log 5 squared is 5 raised to x into 5 raised to x into dx. We normally substitute e raised to x as t. The derivative is back to e raised to x. Same thing. This is another exponential form, but it's not e, it's a. So you have to divide with the log a for integration and multiply with the log a for differentiation. I hope everybody is clear. Option C is your answer. Yes? Got it? So only these many steps those are asking. So one more question. Then is asking, so is one more question? Yes, definitely. The middle one you call it as t. You just did 4 steps. You just had to do 4 steps. Okay, so it's a normal 1 mark question for integration. Question number 13. Again, this is based on the idea that when you multiply e raised to x with the sum of a function and its derivative, the answer is always e raised to x into f of x plus c. A highly expected property based question for 1 mark. So here I am going to split the numerator of the bracket using 1 and sin x so that I'll get 2 terms, all of you. The 2 terms are 1 by 1 minus sin x, then sin x by 1 minus cos x. Denominator is 1 minus cos x. 1 by 1 minus cos x minus sin x by 1 minus cos x. And 1 minus cos x is 2 sin squared x by 2. It's a trigonometric result. What is 1 minus cos x? 2 sin squared x by 2. Sin x is 2 sin x by 2 cos x by 2 divided by 2 sin squared x by 2. Answer is done, my dear students. Once the formula is applied, the result is ready. Now can I take out sine and sine squared here? 2 and 2 here. So this answer is now integral e raised to x into cosec squared x by 2 by 2 minus cot x by 2. I want everybody to tell me what's the derivative of minus cot x by 2. Derivative of minus, so make this as plus and put the minus here. Derivative of minus cot. Derivative of minus cot is plus cosec squared x by 2 into 1 by 2, which is this. It's a direct derivative form, no doubt. You don't have to think too much also, because it's a property. So definitely the derivative of minus cot x by 2 should be cosec squared x by 2 by 2. Okay, so the answer is e raised to x into f of x, which is minus cot x by 2 plus c. So minus e raised to x cot x by 2 plus c. Option B, minus e raised to x cot x by 2 plus c. Okay, yes, 3 of you said the answer, Abin, Prapti and Ritika. Okay, Adil also now. So minus e raised to x cot x by 2 plus c. So all of you please try to understand the basic idea for a question for 1 mark which looks like e raised to x and multiplied with the bracket is f of x plus f dash of x is equal to e raised to x f of x plus c, and you just have to write it as the sum of two functions f of x and f dash of x, and you will clearly get that in the form of f and f dash. Just have to write it. Don't be confused and verifying whether the derivative is there or not. It will be there. Okay, you just have to get the right function, that's all. Okay, moving on, my dear students. Question number 14. Question number 14. The integral of e raised to x into log a multiplied with e raised to x into dx. This is a very common form. Let me circle this. It's a very common form nowadays. I'm going to take it separately here. Do you see that e and log are coming together? These two are inverse of each other. We have to somehow get them together. So the coefficient of log will become the power according to log property. So it becomes e raised to log a raised to x. And according to log property, e and log are inverse. They eliminate themselves. So my answer is actually a raised to x. So this is the actual integral a raised to x into e raised to x into dx. Both the bases have the same power, so it's actually ae raised to x dx. It's the integral of an exponential form a raised to x. The integral of an exponential form a raised to x, which is a raised to x by log a plus c. Here my constant a is a into e. A is an arbitrary constant. E is an Euler's constant. Multiply them together, you will get a new constant, that's all. So constant raised to x is constant raised to x by log constant. So a raised to x by log a. Option C. A raised to x by log ae. Question number 14 clear? Yes, but this idea is what I want you to be learning. This kind of a question is also a good one where you have e and log coming together. The expression will look complicated initially, but try to connect e and log. When they brought together, they eliminate each other and you will get the answer in this form. It's a very, very common question nowadays. Okay, good. Question number 15. Integral of f of x is g of x. Then integral of f of x into g of x into dx. This is again a question based on antiderivative. Listen carefully. Integral of f of x is g of x. According to the idea of antiderivative, f of x is the derivative of g of x, g dash x. Integral antiderivative goes there, becomes g dash x. Now they are asking me to evaluate the integral of f of x into g of x. Property of isolate or integration by parts, and which function should be considered as u and which function should be considered as v, so that I will get g dash x. Very, very important. You cannot simply take and do by parts. You have to take this as u because we take the derivative of u and g dash of x is coming here. So u into integral of v minus the integral of derivative of u into the integral of v. All of you, f of x integral is g of x, so we get g of x into g of x minus integral of g dash x into g of x. Yes, g dash x into g of x. But g dash of x is f of x. G dash of x is f of x. Apply that result over here. Okay, so my answer is going to be g of x whole squared minus integral f of x into g of x. And if I had called this as I, this entire thing is going to be called as I, and this is again I. Integral f of x g of x. Bring it to the left side, you will get 2i is g of x squared. Then what is I? What is I? It's g of x squared divided by 2. G of x squared divided by 2. Option B, g squared x is g of x the whole squared divided by 2, half g squared x. Okay? Okay, clear all of you? Any doubts? Any doubts? You can ask. Nobody? So answer option B is coming. Okay, moving forward. Question number 16. Question number 16, all of you. Integral 0 to pi by 2 square root of 1 minus sine 2x. 1 minus sine 2x is the trigonometric identity, which is cos x minus sine x the whole square. And because it is whole square, under the root it goes off, so you can write it as modulus cos x minus sine x. Because it is coming from inside the square root, cos x minus sine x comes in a modulus. But keep in mind, the limit is from 0 to pi by 2. That's the most dangerous thing here. This is a common question. So the limit is from 0 to pi by 2. Modulus can be positive cos x minus sine x or negative cos x minus sine x, which is sine x minus cos x. Both are possible. So when does cos x minus sine x remain positive? When the limit is from 0 to 45, pi by 4. Because when you start from 0, cos 0 is 1, sine 0 is 0. But when it reaches 45 degrees, they become equal. So they remain positive from 0 to pi by 4, but negative from pi by 4 to pi by 2. So this is how you have to do it. Yes, apply the limits all of you and integrate it first. Integral cos x sine x plus cos x from 0 to pi by 4, and this is minus cos x minus sine x from pi by 4 to pi by 2. Find each of the values and add it. When I apply pi by 4, it's going to be sine pi by 4 plus cos pi by 4, 1 by root 2 plus 1 by root 2, 2 by root 2. Sine 0, 0, cos 0, 1. So 2 by root 2 minus 1 is the first answer. The second one is completely minus. So I'm taking the minus out. Cos 90 is 0, sine 90 1 minus. Cos pi by 4 1 by root 2, sine pi by 4 1 by root 2, again 2 by root 2. So this is minus 1, minus 1, minus 2. 2 by root 2 plus 2 by root 2, 4 by root 2. Rationalize this, you'll get what? 2 root 2 minus 2. 2 root 2 minus 2. And if you take the 2 common out, 2 into root 2 minus 1. 2 into root 2 minus 1. This is your answer. But the common mistake you're going to do is, you will not split them into two parts. You will not split this into two parts. You will do it right away and you will come to the answer 2. You will not get that 2 root 2 form. So please remember, you have to split it as a modulus of two parts. Remember, 0 to pi by 4 is positive part. Pi by 4 to pi by 2 is the negative part. I believe everybody is clear. Please practice this question very well. It's expected, so please learn it thoroughly. Moving forward to the next question, all of you. Question number 17. It's again a modulus question. You have done this in regular classes. Modulus of x plus 1 is going to be in two parts, positive and negative. And this positive and negative breaks at greater than 1 and less than, sorry, not greater than 1, it's minus 1. Okay, it's minus 1. Greater than minus 1, less than minus 1. Why is it minus 1? Because minus 1 is what makes this 0. So greater than minus 1, it becomes positive. Less than minus 1, this becomes negative. So my function is going to be broken at minus 1. So my integral is going to be from minus 2 to minus 1 for the negative part. For the negative part. And minus 1 to 4 for the positive part. If you are not interested in doing this with the negative sign outside, I personally feel a lot of students make mistake when you leave the negative sign here. We can apply the property of definite integrals to get rid of the negative sign by simply reversing the limits. Just reverse the limits. It will help you to neglect the negative sign. Write it as minus 1 to minus 2 x plus 1 and minus 1 to 4 x plus 1. Now you have to integrate it. Integrate it quickly, all of you. Integral is x squared by 2 plus x from minus 1 to minus 2. Then x squared by 2 plus x from minus 1 to 4. Apply the limits. Minus 2 squared is 4 by 2, which is 2. Okay, minus 2. Minus 2 squared is 4. 4 by 2 is 2 minus 2. Upper limit done. Minus lower limit minus 1, that is 1 by 2 minus 1 plus 4 squared by 2, 16 by 2, 8 plus 4, then minus 1 by 2 plus minus 1. Minus 1 by 2 squared, I'm sorry. Minus 1 by 2 is 1 by 2 minus 1. Okay, so we just applied the limits over there. I believe everybody understood it. So 2 minus 2 gone. So it's minus half plus 12 plus half. So it's 13. Answer is 13. Option B, 13. Okay, option B, 13. Nobody got the right answer till now? Yes, one of the answers came now, half is. Okay, good. So option B is 13. So I wouldn't say it's very important, but the idea is just to teach you that whenever you see a modulus with definite integrals, split them into two parts. But the next question is very important. Learn it. 0 to a. Here, they haven't given us what is the upper limit. But they gave the answer for this is pi by 8. You have to find the upper limit. All of you, integral 0 to a 1 by x squared plus 2 squared dx is pi by 8. And this is a standard formula, 1 by x squared plus a squared, 1 by a tan inverse x by a. And the limit is from 0 to a, pi by 8. Apply, please. So the half will go there. If the half goes there, it becomes pi by 4. So it implies tan inverse a by 2 minus tan inverse 0 equal to pi by 4. Tan inverse 0 is 0. So tan inverse a by 2 equal to pi by 4. No doubt, a by 2 equal to 1. Because we know tan pi by 4 is 1. That implies a is equal to 2. A is equal to 2, option B. A is equal to 2, option B. Yes, right answer coming from Abin, Prapti, Faris, Hafiz, Sana, Samuel and Shadi. Good, fine. So it's a very, very important question. Please mark it and learn it. Finding one of the limits when the answer of the definite integral is given to you. It's a simple question. Practice it. It's good. Next one. 2 to 3 x by x squared plus 1. Standard question. And it's a method of substitution, or you can create that f dash of x by f of x. I'll simply multiply half and multiply 2. So this now looks like the integral of f dash of x divided by f of x, which is log f of x. Apply that formula, please, all of you. You will get the answer as 1 by 2 log x squared plus 1, and the limit is from 2 to 3. It's going to be 1 by 2 log 3 squared plus 1 is 10 minus log 2 squared plus 1 is 5. Log 10 minus log 5. According to property of log A minus log B is log A by B, which is half log 2. Half log 2. My dear students, don't mind if I go a bit fast today, because integration we have a lot of important questions and we have to get those questions today itself. That's why I'm moving a little bit faster, but some of you are able to catch up. They're giving the answers very good. Option D has come from many of you already. So please remember this question which I said is done using f dash by f of x. You can keep this in mind. Many questions this property is going to be useful for you. Question number 20, again standard EX Fn f dash. Okay, standard question. This is integral of e raised to x cos x plus minus sin x, and you can clearly see this is your f of x and this is your derivative f dash, because derivative cos x is minus sin x. So your answer is going to be e raised to x into f of x, and the limit is from 0 to pi by 2. Apply the limits. E raised to pi by 2 cos pi by 2 minus e raised to 0 cos 0. Cos pi by 2 is 0, so first part is 0. E raised to 0 is 1, cos 0 is also 1. Final answer minus 1. Option B, minus 1. Right answer, Prapti, Nitin, Shadi and Hadia. Okay, so answer is minus 1. Careful. 21. Value of integral e to e squared dx by x log x. Again, this x can be treated like 1 by x dx by log x, and this again looks like integral f dash by f, which is log f. Hence my answer here is log f is log x. Log f is log x, and my limits are e and e squared. Apply the limits. Log of log e squared, log of log e. What's log e? 1. And what's log 1? 0. So this whole part is 0. Now how to do this part? According to the property of log, the power can be brought down as 2 log e. And log e is again 1. So answer is log 2 into 1, which is log 2. So final answer, log 2, option B. Log 2, option B. Right answer, yes, Nitin, Abin, Shadi and Faris. Good. So answer log 2. Again, 0 to 1, 0 to 1, the derivative form. The derivative of tan inverse x is 1 by 1 plus x squared. So if I put t as tan inverse, what's the derivative? Dx by 1 plus x squared, right? So I can write this integral as dt or t dt. Okay, t dt. Either you can choose to change the limits here itself, or after integrating put back t and then substitute the original limits. That's your choice. So I am going to be writing it as t squared by 2 which is tan inverse x the whole squared by 2, and apply the limits now as 0 to 1. I am not trying to change the limits here. It's not a complicated expression to change the limits. So it's going to be tan inverse 1 whole squared by 2. 0 no need because it's 0. Tan inverse 1 is pi by 4 squared by 2. Tan inverse 1 pi by 4 squared by 2. Pi by 4 squared is pi squared by 16 and 2 is 32. Pi squared by 32. Option, sorry, that's not pi squared. This is pi squared. Pi squared by 32. Option D. Right answer coming from Prapti, Abin, Faraz, Adil, Hadia, Nitin and Jed. So answer D, pi squared by 32. Answer D, pi squared by 32. Question number 23. A standard form and repeatedly taught to you in every class of application of integrals, that this is a very common formula when it comes to application of integrals, area under a circle or an ellipse. Formula: x by 2 root of a squared minus x squared plus a squared by 2 sine inverse x by a. Apply this formula inside the integral, all of you. So the question will give you the answer as x by 2 root of 4 minus x squared plus 4 by 2 sine inverse x by 2 from 0 to 2. Apply the limits, all of you. If I apply 2 here, 4 minus 4 will become 0, and your upper limit gives you only 2 sine inverse 1. When I apply 0, this term is 0 and this term is also 0. So forget about the entire thing. So 2 into pi by 2, answer is pi. This often happens for these kind of integrals. When you try to put the lower limit 0, this entire expression becomes 0, so you need not put it. Forget about 0. When you try to put the upper limit, most of the times the square root term will disappear. So the answer is simply pi, option A. Pi, option A. Right answer: Abin, Nitin, Shadi, Hadi and Hafiz. Good. Fine. Moving forward, students. Question number 24. Again, modulus. Modulus. So modulus, you know how to do it, right? You have to split it into two parts. And this is simply mod x, which is going to become positive for greater than 0 and negative for less than 0. And the 0 is between minus 1 and 1. So I will break my interval as minus 1 to 0, less than 0, where mod x is minus x, and then 0 to 1, where mod x is plus x. What is the integral of e raised to minus x? By minus 1. And what is the integral of e raised to x? E raised to x. Apply 0. E raised to 0 is 1 by minus 1. Apply minus 1. E raised to 1 by minus 1. Then e raised to 1 minus e raised to 0. 1 by minus 1, no doubt, minus 1, plus e minus 1. E plus e, 2e. Minus 1 minus 1, minus 2. 2e minus 2, which is 2 into e minus 1. 2 into e minus 1. Okay? 2 into e minus 1. Option C. Yes, right answer. Yes. Many have given the right answers. Let's not waste time. I want to do one more question for today. The last question, number 25. How to integrate a greatest integer function? How can we easily do it? How to integrate a greatest integer function from 0 to 3? What I'll do is, I will simply break them into 0 to 1. Okay. Then I'll make it 1 to 2, and then I'll make it 2 to 3, because greatest integer is a broken function where it's broken with each integer part, right? 1 to 2, 2 to 3, 3 to 4, like that. So you have to break it like that. Now whatever be the value from 0 to 1, the greatest integer of that is 0. Yes, the greatest integer, whatever be the value, the greatest integer is going to be 0. For 1 to 2, the greatest integer is 1. For 2 to 3, the greatest integer is 2. So this is 1 to 2, this is 2 to 3. What is the integral of 0? No need to do, it's still 0. Integral of 1 is x with the limit 1 to 2. And integral of 2 is 2x 2 to 3. I taught you how to integrate mod x mod x by 2. Same way, teaching you how to integrate greatest integer function, and that will be definitely with limits. You just break them into small parts like this, each integer part. Okay, so 2 minus 1 plus 6 minus 4. 2 minus 1 is 1, 6 minus 4 is 2. Answer 3. Answer 3. Option D. Answer 3, option D. Okay, so that's enough for today. And as I said in the beginning, this is the last class for MCQ discussion of your YouTube classes, live classes. So we'll be coming back again. Brilliant is coming back again for you with a rapid revision starting on 24th with chemistry. Okay, and we'll be sending you the details of the classes for 3 days. For each subject we are dedicating you for YouTube live classes, rapid revision on the subjective type questions, important tips on how to understand each subjective question and how to learn from each topic, and important questions from each topic. Please try to attend those sessions as well. It's only going to be 2 hours per day for 3 days only for each subject, starting on 24th with chemistry, and then followed by physics, and then math, and then bio. So I want everybody, or we want everybody to attend those sessions, and we will be helping you throughout your CBSE board examinations. We'll be staying in touch with you, and thank you all of you. Have a very, very nice day and nice examination. Good night all of you. Thank you, dear students. See you all again. See you all again soon. Very soon.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.